Bismillahirrahmanirrahim. Assalamualaikum and very good not sure, so now is afternoon, so very good afternoon. And so I hope you guys are ready to face this 2021. So because this year is very crucial for you guys, because you guys will sit for SPM. Okay, so please don't worry about the syllabus, because we will try to work it out together. Alright, so please don't be so worried about the syllabus. Okay, and also the format is actually is just the same, but you guys have to be more diligent so that you will not having a problem for this coming SPM. Alright, so first of all, so I will like to explain to you what we will learn for today. So since we will be having a one period class, so I decided to make a video so that it will not wasting our time waiting for our friend to come to class. Alright, so for this for today we will do some revision about Gravitation chapter 3 form 4. So I hope you guys still keep the handout and also submitted your homework. Okay, so for today we will only discuss a little bit about the universal law of gravitation. Okay, so so I'm sorry, so we will look at the learning objective. Okay, so number 1, so Newton's universal law of gravitation. So Newton's universal law of gravitation, so first you have to know what so you have to know how to explain the Newton's universal law of gravitation. So Newton's universal law of gravitation, so kita dah belajar. So it have two law, so number 1 and number 2. So number 1 we have when the force is directly proportional to the product of two bodies. Okay, so we can write it like this. So F is directly proportional to M1, M2. Okay, so next the second law is when the force is inversely proportional to the square of distance between the center of two bodies. Okay, so we can write it also. So F is inversely proportional to R squared. Okay, so you have to remember the keyword here, so the center of two bodies. Okay, so next the next learning objective, so solve a problem involving Newton's universal law of gravitation. Okay, so daripada two law tadi, so we can come out with one formula. So when F is directly proportional to M1, M2 and inversely proportional to the distance, the square of distance. So to change this symbol, so here to change this symbol to equal, so we can write it F equals to G. So G is a constant, so M1 M2 over R squared. Okay, Alright, so here we have a new we have a formula here, which is you already know about. Okay, so next, to solve a problem involving Newton's universal law of gravitation, which is F equals to G m1 m2 over r squared. Okay, so when we have two static object on the earth. Okay, so kita ada satu objek yang pertama, and the second one a much bigger object. Alright, so we have two objects on the surface of the earth. So kita ada m1 and m2. So we have the radius. Okay, so here we can find the formula. So G m1 m2 over r squared. Okay, so between two bodies, so we will write it like that. Okay, so the object on the earth. Okay, so when we have the earth, so earth kat sini, so earth, the value is constant, it's not changing. So when the value is constant, so m dia akan jadi capital M besar. So kita tulis je sebagai constant mass of earth. Okay, so and the object on the earth, so object ni tadi dia m kecil. Sebab apa? Sebab dia variable. Okay, so we can rewrite the equation, the universal law of gravitation. So we have F equals to G m besar m kecil over, and also we have the distance between the center of the earth and the center of the object on the surface of the earth. So G m over r squared. Okay, so next, when we have the earth and the satellite. Okay, so this one we will come up with a different formula. Okay, so this one is the first one, the second one, and the third one when the earth and the satellite. So we have earth, so let's say earth ni tadi sama juga constant, so m besar, and also the satellite, satellite ni kita buat macam lalat sikit. Okay, so m variable, so we can, the mass of the satellite is changing, depends on the type of the satellite. Alright, so next, now we have a very tough one. So usually, so the question will give you the height of the satellite from the surface of the earth. Okay, so the height is here, h, and the value of r here must be from the center of the object. Okay, so now we have to find the we have to include the radius of the earth. So the radius of the earth, constant. So radius berubah ke? Adakah the size of the earth is changing in time? Not right. So radius of the earth is constant, so that we write its r capital. Okay, alright, so how can we find the r kecil? So r kecil is when r equals to r radius of the earth and the distance of the satellite from the surface of the earth is h. So after that we can plug in into the formula. So we have F equals to G m over r plus h squared. Okay, so next apa? the force the force between the earth and the sun. Okay, so we have the earth and also the sun. Okay, so sun is of course much bigger than the earth. Okay, so we can assign so which one is M besar and which one is M kecil. Alright, so the formula is also the same. So F equals to G M over R squared. Alright, okay. So now we have 1, 2, 3, 4 formula to memorize. Okay, so next we will look at 3.1. Okay, so 3.13. Okay, so relate gravitational acceleration G on the surface of the earth. Yang biasa kita belajar. So G kecil equals to 10 meter per second squared. So of the earth with the universal gravitation constant G. Okay, so macam mana kita nak samakan dia? Okay, so kita tengok. So we have two things. So the first one, the Newton's second law of motion. Apa dia Newton's second law of motion? So we have F equals to mg, and also Newton universal law of gravitation. So we have F equals to G M besar M kecil over R squared. Okay, so equate both because we have two, force and force. So mg equals to G M over R squared. So M kecil kita boleh potong. So kita dapat, so G equals to G M over R squared. Itu dia the relationship between gravitational or acceleration on the surface of the earth with the universal law of gravitation. Kat sini dia silap sikit, so kena G besar. Okay, so the factor that affect the gravitational acceleration, so mestilah R kecil. Sebab apa? Sebab G dengan M constant. Okay, so kita tengok balik. Alright, so justify the importance of knowing the values of gravitational acceleration of the planets in solar system. Kenapa kita kena tahu the gravitational acceleration of a planet in the solar system? So this is your work. Okay, so one thing kita dah bincang waktu activity, ingat lagi tak? Okay, so I hope you can revise it later. Alright, so describe the centripetal force in the motion of satellite and planet system. Okay, so centripetal force, so formula for centripetal force is mv squared over r. Ini kita panggil dia centripetal force. Okay, alright. So determine the mass of the earth and the sun using universal law of gravitation and centripetal force. Yang ni kita boleh tengok balik dekat modul. Kamu pun boleh tengok balik dekat modul kamu. So macam mana kita nak determine the mass of the earth and the sun using the universal law of gravitation and centripetal force formula. So I hope you can do revision after this. Alright, so now we will continue. So the Kepler's law, also you can do some revision about it, and also man-made satellite. Okay, so and also the escape velocity lah. Alright, So we already learned about this last year. So I hope you can do some revision. If you have any question, you can ask me. So I'm always available through WhatsApp. Okay. Alright. So next we will discuss on the exercise from the handout. So the first question. Okay, so number 1, A, communication satellites orbit the Earth at the height of 36,000 kilometer. Okay, so we have here height is equals to 36,000 kilometer. So ingat, so bila kilometer kita kena tukar kepada meter. So the multiplier for kilo is 36,000 times 10 to the power of 3. Multiplier ingat lagi waktu form 1 dah belajar. Okay, so how far is this from the center of the Earth? So given the radius of the Earth is 6. So R besar equals to 6.4 times 10 to the power of 6 meter. So macam mana kita nak cari? Ingat lagi, so R kecil sama dengan R plus H. So 6.4 times 10 to the power of 6 meter plus 36,000 times 10 to the power of 3 meter. So tekan calculator, so you will get 4.24 times 10 to the power of 7 meter. Okay, so this is the value of R, the distance between the satellite and the center of the Earth. Okay, so next, alright, so here we go, question number 1B. So if such a satellite has a mass of 250 kilogram, so what is the force of attraction on it from the Earth? So we wanted to calculate for the value of F. Okay, so kita gunakan universal law of gravitation. So F equals to so mass of the Earth, so mesti guna M besar. So G M besar, M kecil over R squared. So R kita dah kira dekat atas, so plug in the value. So G is 6.67 times 10 to the power of negative 11. So mass of the Earth 6.0 times 10 to the power of 24, and also the mass of the satellite is 250 kilogram. So R squared, ambil yang atas ni, 4.24 times 10 power of 7 meter squared. Selalu silly mistake, tertinggal squared. So tolong jangan buat. Alright, so you will get the answer is 55.65 Newton. Okay, so next, question number 2. Okay, so two spherical objects have mass of 200 kilogram and 500 kilogram. So their center are separated by a distance of 25 meters. So find the gravitational attraction between them. Okay, so both of these mass object have on the surface of the Earth. So bila kita ada dua-dua on the surface of the Earth, so we use formula F equals to G M1 M2 over R squared. So ini senang je. So plug in the value of constant G. So 6.67 times 10 power of negative 11. So mass number 1 200 and mass number 2 500 over R squared 25 meter squared. Okay, remember, I always try to improvise you so that you don't forget to put square there. Sorry. Okay, so you will get the answer 1.0672 times 10 to the power of negative 8. So first unit Newton. Alright, so question number 1, question number 2 is done. So now we move on to question number 3. Okay, so this is question number 3. So diagram 1.1 shows an athlete spinning a 7 kilogram hammer in a sport. So diagram 1.2 shows top view of the spinning. Okay, so bila dia berpusing, based on the diagram 1.2, name the force that make the hammer move in the circle path. So bila circle path, of course it is a centripetal force. Alright. Okay, so the direction, okay, so mark on the diagram 1.2, the direction of the force stated in A1. So bila the direction of centripetal force is always pointing towards the center of the force. Okay, so dia towards, kita guna warna lain lah. Okay, so towards the center. Alright, so next, so if the hammer move with a constant velocity 25 meter per second, so calculate the force stated in A1 that acts on the hammer. Okay, so kita ada V, sorry, kita guna warna hitam balik. So V equals to 25 meter per second. So force, so the formula for centripetal force, so F equals to mv squared over R. Okay, dekat sini dia ada bagi tahu, so mass of the hammer is 7 kilogram. So M equals to 7 kg, and also the R is here 2 meter. So R is 2 meter. So kita boleh masukkan semua nilai 7 times 2, 7 times 25 squared over 2. So kita akan dapat 21875.5 Newton. So this question carry 2 marks. Okay, so how does the movement of the hammer when the athlete release the string? Okay, so bila dia lepaskan string tu, macam mana movement of the hammer? Okay, so it move in straight line in direction of the tangent. So ingat lagi, tangent is 90 degree at point release. Okay, sorry lah tulisan buruk sikit. Alright. So done question number 3. So next question number 4. Okay, so diagram shows an object A on the surface of the earth and object B at height h from the earth. So R is the radius of the earth and R is the distance of the object and from the center of the earth, and M is the mass of the earth. Okay, so based on the information above, derive the gravitational acceleration in terms of G, M, R, and H for object A. Okay, so object A, they stay on the surface of the earth. So maksudnya G dia adalah G daripada second law of motion, which is So force dia adalah F equals to mg. And also we have a universal law of gravitation. So force G M besar M kecil over R squared. So when we equate both equations, so mg equals to G M over R squared. Sebab sini dia suruh cari G, gravitational acceleration of the object. Okay, so kita potong M kecil, so tinggallah G equals to G M over R squared. Okay, so now for object B. Okay, so kita nak cari dia punya G. Okay, so object B dia lain sikit. Sebab apa? Okay, sorry. So for object A, so dia ada dekat surface of the earth. So that's why R dia kita kena substitutekan dengan the radius of the earth. Okay, so that's why G M over R besar square. Okay, so next object B. So object B dia ada height, so dia punya R dia adalah R plus H. So F equals to mg, F equals to G M over R squared. So when we both equate the equation over R squared, so kita gantikan R tu. So kita dah boleh potong dah siap-siap M ni. So tinggal GM. So R ni gantikan dengan R plus H squared. So G equals to GM over R plus H squared. Okay, so this is the final answer. Alright. So next kita akan tengok question B. So given the mass of the earth is 5.97 times 10 to the power of 24 kilogram. So radius of the earth is 6.37 times 10 to the power of 6 meter. So universal gravitation constant is 6.67 times 10 to the power of negative 11 Newton meter squared per kilogram squared. So calculate the value of gravitational acceleration of the object A. So kita ambil je formula yang kita dah kira kat atas ni, yang kita dah derive dekat atas ni. So G equals to GM over R squared. Okay, semua maklumat dah diberi. So 6.67 times 10 power of negative 11 times dengan mass of the earth 5.97 times 10 power of 24 over 6.37 times 10 power of 6 squared. So kita akan dapat nilai dia adalah 9.81 Newton per kg. Okay. Alright, so next question. The gravitational acceleration of object B at 345 kilometer height from the surface of the earth. Okay, so G tadi sama dengan GM over R plus H squared. So kita nak cari G. G kecil, so 6.67 times 10 power of negative 11. Mass of the earth is I don't remember yet, sorry. 5.97 times 10 power of 24 over R besar. So radius of the earth, semua nilai dibagi 6.37 times 10 power of 6 plus H. H ni dah bagi kat sini, so kena tukar kilometer, tukar kepada meter. So 345 times 10 power of 3. So yang ni kita square kan, jangan lupa semua ni square kan. Okay, so the value we get is 8.83 Newton per kg. So the satellite is so object B is orbiting around the earth at gravitational acceleration of 8.83 Newton per kilogram, which is smaller than the gravitational acceleration of object A, which is stated on the surface of the earth. Okay, so makin jauh the object from the earth, the gravitational acceleration pun akan decrease. Alright, so next kita tengok. So diagram 3 shows question number 5 already. Okay, so diagram 3 shows a satellite with mass 102 kg orbiting the earth at 3,500 km height from the surface of the earth. So gravitational acceleration at the surface of the earth is 9.81 meter per second negative 2, and the radius of the earth is 6370 kilometer. Alright, so what is the centripetal force? Okay, so it asks, okay, so the question asks us, what is the what is the definition of centripetal force? So centripetal force is a force that makes body to follow a circular path with direction always towards the center of curvature. So it's always explain about what is centripetal force. Okay, so a force that makes the body to follow a circular path with the directions always towards the center of curvatures. Macam tu. Okay, so what is the orbital radius of the satellite? So dia tanya kita dia punya orbital radius. So bila orbital radius, yang distance tu R kecil, so maksudnya R besar plus H. Alright. So how can we get the value? So the H is 35. So the value of the radius of the earth is 6370 kilometer plus the height is 3500 kilometer. So easy. So you will get 9870 kilometer. Okay. So 1 mark only. Alright, so next question. We already reached towards the end. Okay, so what is the gravitational acceleration at the position of the satellite? What is the gravitational acceleration at the position of the satellite? Okay, so the question asks us to calculate the gravitational acceleration at the position of satellite. Okay, so kita cari balik formula dia tadi. So terbesar pula. So G equals to Gm over R plus H square. Okay, so nilai G ada, nilai M ada, so mass of the earth, and also nilai R and nilai H. Okay, so we can calculate it. So G is 6.67 times 10 to the power of negative 11, and the mass of the earth is, what is the mass of the earth? I forgot already. So the mass of the earth is 5.97 times 10 power of 24 over R. So tadi R kita dah ada berapa tadi? 63 something, 6370 kilometer. Okay, so kita kena tukar jadi meter times 3 plus 3500 Alhamdulillah times 3 square. Okay, so push your calculator. So for this one I want to show you 6.67 exponential negative 11 5.97 exponential 4 divided by 6370 exponential 3 plus 3500 exponential 3 squared. So we will get 4.0876. So bagi je lah berapa banyak yang kita dapat. So kita dapat mana ada times dah. So bila gravitational acceleration, so meter per second square. Alright, so next, what will happen to the gravitational acceleration if the height increase? Saya dah cakap dah tadi. So bila height increase, so apa jadi pada gravitational acceleration? Dia akan height decrease. So bila height decrease, so makin dekat dengan bumi, so gravitational akan increase. Macam tadi contoh kita ada yang dekat on the surface, dia punya G sama dengan 9.81 meter per second negative 2, tapi bila objek tu jauh, dia punya G sama dengan 8.83 meter per second negative 2. So maksudnya bila dia menghampiri bumi, so the value of gravitational acceleration will increase. Sebab apa increase? Because the radius of the orbit decrease. Okay, so it is all playing with the what we call it, a relationship. Alright, so for next question, question 6. Okay, so for question 6, so Venus and Mars are planets in our solar system. So the acceleration due gravity and the escape velocity in both planets are different. Okay, so escape velocity, kita dah belajar. Acceleration due to gravity, kita dah belajar. Okay, so the mass and the radius for both planet ada dekat bawah dalam table. So kita ada acceleration. So the question asks us to calculate for the acceleration due to gravity at Venus and Mars. Okay, so formula for gravitational acceleration, kita dah buat dah tadi. Yang tadi G equals to Gm over R squared. Okay, so G constant of gravitation, so 6.67 times 10 power of negative 11. So mass, okay, so yeah, the first one we wanted to calculate for the Venus, so G for Venus. Okay, so mass dia 4.87 times 10 power of 24, and the R is 6.05 times 10 power of 6 squared. So we got the answer for this one, 8.84 meter per second squared. So next we wanted to calculate for Mars. So Gm over R squared, so sama juga 6.67 times 10 power of negative 11 times dengan what is it, 6.42 times 10 power of 23, sorry, over 3.40 times 10 power of 6 squared. Dengan tinggal squared. Okay, so gravitational acceleration for Mars is 3.70 meter per second negative 2. Okay, so next question, escape velocity at Venus and Mars. Okay, so formula for escape velocity, so V equals to 2gm over R. Kena hafal formula, banyak sangat formula untuk gravitation ni. Okay, so 2 untuk Venus dulu. So 2, 6.67 times 10 power of negative 11. So mass of Venus berapa? So mass of Venus okay, so kamu boleh masukkan semua nilai. So escape velocity for Venus is 1.04 times 10 to the power of 4 meter per second, and escape velocity for Mars is 5.02 times 10 to the power of 3 meter per second. Tak susah pun, just masukkan dalam formula. So ada formula dekat situ, ada jawapan, so you will get full mark. Alright, okay, so next, the video is going too long. Compare the value of acceleration due to the gravity and escape velocity for both planet. Okay, so Mars less than Venus. Kenapa Mars less than Venus? Explain your answer. Because Mars have smaller mass. Okay, tengok mass dia lebih kecil daripada Venus. Okay, so I think we can stop at question number 6. So we will continue on question number 7, 8 and 9 for the next video. Alright, I think that's all. Thank you guys.